Nucleophilic substitution reactions versus elimination reactions, right? In the last video we discussed about nucleophilic substitution reactions. These nucleophilic substitution reactions are two types. Those are SN1, SN2. Nucleophilic substitution reactions, bimolecular and unimolecular. Next here, elimination reactions, also two types. Beta elimination, generally it is one is E1, the other one is E2. Okay, in case of E1 and SN1, intermediate is forming. Intermediate is forming, right? In SN2 and E2, in SN2 and E2, no intermediate, no intermediate. Transition state is there. Transition state, right? Transition state is there. So now, if alkyl halide is there, so either it is undergoing SN1 or SN2 or E1 or E2. Now four options are there. So how to decide? See, first one. Here that depends on nucleophiles. That depends on the nucleophile if and basic character. Nucleophile and basic character. So we can see here, if nucleophile and basic character mean nucleophile is strong and base also strong. Okay, nucleophile and base both are strong. Suppose example is OH minus is there. This OH minus is strong nucleophile as well as strong base also. Okay, it's not visible. CH3 minus and OH minus. Generally, these charged particles are stronger. So strong nucleophile and strong base. In this case, the primary alkyl halide, you know that primary alkyl halide CH2X, this is the primary. If X is attached with this carbon, it's secondary. If X is attached like this, tertiary, right? So primary alkyl halides, these all are alkyl halides, primary, secondary, tertiary. These are undergoing SN2. We know in the last video we discussed SN1 order is tertiary is greater than secondary is greater than primary. SN2 is reverse. Primary is higher than secondary than tertiary, right? So in case of strong base and strong nucleophile is there, if it is primary alkyl halide, obviously it's undergoing SN2. Suppose if it is secondary alkyl halide, chances are there it undergoes E2 reaction. Then if tertiary is there, it's undergoing again E2. Tertiary and secondary, these both are undergoing E2 reaction. So the conclusion is, if stronger base and stronger nucleophile is there, either SN2 or E2. Okay, if it is primary, obviously SN2. If it is secondary, then secondary or tertiary, more chances are there E2 elimination. There is no E1 elimination. Okay, right. Suppose stronger nucleophile and weaker base is there. In that case, the primary alkyl halide The primary alkyl halide undergoing again SN2. Why SN2? Stronger nucleophile is there. Whenever stronger nucleophile is there, maximum SN2. Then secondary also SN2. Secondary also SN2. Okay. Elimination. Sorry, tertiary. Tertiary, it's there is no. We cannot decide here. Right. Next. Suppose weak nucleophilic, strong base is there. Strong base. See here examples for strong and weak. Suppose I all halogens minus halide ions here. Okay. Then cyanide Cn minus. These are strong nucleophile but weak base. Weak base. Right. Now nucleophile, weak nucleophile, strong base. Those are H minus, hydride ion, NH2 minus, amide ion, then nitrogen bases and tertiary butoxide. Tertiary butoxide. Okay, like this. Even LDA. Okay, these are the weak nucleophile, strong base. Okay, now in this case, the primary alkyl halides undergoing E2 elimination, right? Secondary also undergoing E2 elimination, then tertiary also undergoing E2 elimination. So whenever weak nucleophile means what? Generally nucleophile means the negative particle which is attacking on the carbon chain. Okay, these all are nucleophiles. Weak nucleophile means it cannot form stronger bond with carbon. Weak nucleophile means it cannot form bond with carbon. Strong base. Base means क्या है? Generally it is attracting H plus ion. Okay, or it can donate lone pair to H plus. To H plus. Otherwise, it can take H plus from the reactant. It can take H plus from the reactant. That is the base. Now, in case of weak nucleophile means bond formation नहीं हो रहा है, मतलब there is no substitution nucleophilic. Obviously, elimination. In that elimination, here stronger base is there. Strong base means it is taking H minus ion fast. It is taking H minus ion fast. So stronger base is there. So elimination reactions, right? Now, in case of weak base and weak acid, weak base and weak nucleophile is there. Okay, such as examples H2SO4, HCl. These are acting as weak base and H2SO4, weak base and weak as nucleophile. So in that case, primary may there is no reaction, then secondary and tertiary is there. It may be SN1 or E1. Here also same SN1 or E1, right? SN1 or E1. Okay. So step by step we will discuss. So the conclusion is, if you feel little uncomfortable in that table, so here I specified few points. If whenever stronger nucleophile is there, you have to know that stronger nucleophile and weaker nucleophile कब होता है, क्या होता है, ठीक है? Stronger nucleophile is there, generally SN2. Stronger base is there, that is undergoing elimination reaction, E2 elimination. So both are stronger are there, both are means both are means strong base as well strong nucleophile. Then in that case, the primary alkyl halide undergoing SN2, secondary and tertiary are undergoing E2. So it is very clear. Yes. So if you understand clearly, is it stronger nucleophile or weaker nucleophile? Is it stronger base or weaker base? So 90% problem will be solved. Okay. Then both are weak. In that case, we cannot do anything here. So depends on the condition. SN1 and E1. Generally, whenever temperature is there, higher temperature is there, or temperature symbol is there, it is going elimination reaction. Okay, it is undergoing elimination reaction, right? Temperature factor is there. Then based on the types of carbon. So starting we discussed primary hetero either SN2 or E2. Secondary is there SN1, E1 or E2. If tertiary is there, tertiary hydrocarbon is there, obviously SN1. Okay, SN1 or E1. Right. Next. So from the table only this point you can see again table. Charged particles are there. Charged base is there. In that case SN2 or E2 charged is there. Charge matlab 2 ऐसे याद रखो. Charge is there means 2. What is this 2? Either it may be SN or E. Right? If it is a neutral, general concept is 1. If it is a neutral, 1. Either SN1 or E1. If you know these few points, little bit easy. Now see some questions, examples. Right? See, KCN is given, K plus Cn minus. So charged is there. Charged is there means SN2 or E2. Right? Okay. I did not tell you about polar solvents. Yeah, here one more is there. It is missed. If polar solvent is there, polar may two types, protic and aprotic. Polar protic and polar aprotic. If polar protic is there, that is Se2 is higher preference than SN2. What is Se2? That is elimination reaction. E2, we can say E2 or Se2. Suppose aprotic solvent is there, SN2. Aprotic solvent is there, SN2. What are the aprotic solvents? See here, example. Protic solvent means which can donate H plus ions. Which can donate H plus ions. Aprotic means no H plus ions. There is no H plus ion. Okay. Dimethyl sulfoxide. Dimethyl sulfoxide. This is the. So in the protic, polar protic may even H2O will come, alcohol will come. Okay. Carboxylic acid like that. So protic and aprotic, right? Protic is there, polar protic is there, Se2, SN2. Okay, polar aprotic is there, SN2, Se2. Right. See here DMSO. DMSO is non-polar. Sorry, polar, but polar aprotic. Aprotic. That means no hydrogen. No hydrogen. So it will leads to polar aprotic. Again, you can see this table. Polar aprotic is SN2 is more favored. SN2 is more favored. Okay. That means here, first of all, charged means SN2 or E2. Polar aprotic means SN2. Polar aprotic means SN2. Then what is the product here? This is M type is there. Here it will come cyanide. So in the last classes we discussed the cyanide KCN and AgCN. Yes. So whenever KCN is there, obviously CN cyanide is forming. Right? In case of this example, plus and minus charged particles are there. So again SN2 or E2. Here protic is there. Protic. Protic is there means obviously what is the reaction? Protic is there means E2. E2 elimination. So now what is your product here? Like this, here elimination takes place. Have you seen the difference? Protic and aprotic. Charged is there means first of all you have to decide first step. Rough work it is. Right? Then protic is there means E2. Like this. Next. Iodine and methyl is there. Okay. So sodium ethoxide C2H5O minus Na plus sodium ethoxide in the presence of ethanol. In the presence of ethanol, alcohol, C2H5OH. Right? Here, which reaction takes place? First of all, charged. Charged means SN2 or E2. Now, is it protic or aprotic? It is protic. Protic means undergoing elimination. Right? Undergoing elimination. So elimination here, this iodine is there. So elimination here also possible A position and B position. Obviously here more substituted alkene is more stable. That's why your product is like this. Here methyl will be there. Right? So E2 mechanism. Next, is it clear? Next, suppose here iodine is there, stereochemistry also, hydrogen, then sodium hydrogen sulfide Na plus SH minus DMSO solvent. So see, charged means SN2 or E2, right? Here DMSO is there. DMSO is the protic or aprotic? Aprotic. Aprotic. The aprotic means SN2. So SN2 में क्या होता है? This nucleophilic is SH minus. Nucleophilic is attacking. In the SN2, reverse means inversion product. SN2 inversion product. Right? So if you take this stereochemistry also, then obviously it will be in the thick line SH. This will be the dotted line, of course. Okay. Inversion product is giving inversion product. See how you will think. See, this is the towards us. काम करो. Wait. same product you can do like this. This is the SH, then hydrogen, right? Now inversion product. Okay. Next, one more example. NaI. That means Na plus I minus. Then ethyl alcohol. Okay. So which reaction it will takes place? Primary is there and charged is there. Okay. So first of all, it is here the problem is both are nucleophiles. I minus and ethyl alcohol both are nucleophiles. So nucleophilic substitution reaction takes place. Iodine minus 1, 2, 3, 4. 1, 2, 3, 4. Here iodine. Here there is no stereochemistry because all four different groups are there, then only stereochemistry is possible. A, B, C, D, all four different stereochemistry. Okay, here all are hydrogens, the front side, back side, there is no change here. Okay, we can take one more example here for the clear. Sodium DMSO. DMSO. Now this will be same. Which reaction takes place? Na plus SH minus. So SN2 and E2. First of all, SN2 and E2 charged is there. That's why DMSO. So DMSO is nucleophilic substitution reactions. You can see DMSO aprotic. DMSO means aprotic. Aprotic is SN2 is favored, right? DMSO. So SN2. In this case, SN2, the chlorine is there. Here thick line. With thick line, SH will come. So what about this? It will be remain as it is. Remain as it is. Next. Na plus Cn minus. Here acetone. Acetone is there. Acetone also polar but aprotic. Formula is acetone formula like this. CH3, CH3. It cannot donate any H plus. So it is aprotic. Okay, you can write in the rough paper. Protic, aprotic. Okay, then neutral, charged, nucleus, charged nucleophile, right? So charged means here E2, then RSN2. So acetone is aprotic. Aprotic में क्या होता है? SN2 takes place. So now bromine. This SN2 is the inversion product again. So now the product is bromine upside is there. Now I can say dotted line cyanide, right? So like this you have to take, and one more example, last two examples I will give you. Bromine is there, we are taking water, aqueous medium. Okay, of course it's a weak electrophile, weak nucleophile and weak base also. So in this case, generally which reactions takes place? SN1 and E1. If temperature is there, E1 is favored. Okay, temperature is not there, so no temperature. No temperature means SN1 is preferred. So here bromine is there, bromine के जगह पे OH will come. This, so here two products, it will give two products plus. Why it is SN1 mechanism? In the SN1 mechanism, intermediate is there. SN1 means racemic mixture. Racemic mixture. So one more product here, dotted OH means here with dot OH, then thick line methyl group. Okay, this is the conclusion is SN1 mechanism. And see some important and note points are, suppose bicyclic compound is there, bicyclic compound, right? Here tosyl group is there. Tosyl means the good living group. It is good living group. It is good living group. But whenever this position is there, no elimination reaction. This position here, this type of this type of double bond, it never forms. It never form, because here if you keep it this double bond, it is sp2 hybridization, right? Sp2 means planar. Okay, planar not possible, planar, but it is not possible. Okay, three-dimensional, no? Three-dimensional, how it is planar? So that's why it is not possible. So elimination is not there means obviously what it will be. Suppose if you are taking NH3 or whatever base is there, so obviously nucleophilic substitution reaction, that is wherever OTS is there, same place NH2 will come. Okay, and one more reaction, cyclohexane chair structure, chair structure. Now, DMSO, now OH minus is there, K plus, that means SN2 and E2. DMSO is favored SN2. DMSO is favored SN2. So wherever bromine is there, so opposite form OH will come, means OH will come like this. Okay, but it is axial position, so unstable. So immediately it will convert like this, flipping होता है, flipping. So this position, A position going up, right? This position is going up, this B position will coming down. You have to flip like this. You have to like, right? So now B position came down. B position, so OH is upside is there, ABB upside. So this position is called equatorial, right? Equatorial is stable one. It is flipping due to this steric indentation, right? Next, any other compounds? Okay, one more last. Good living group is there. So if you use that NaNH2, Na plus NH2 minus, charged is there, and we are using NH3. Okay, what is this? Protic solvent. Protic. Charged is there means E2, SN2, E2 and SN2. In this, protic is there, that means E2 is favored, right? So your product will be like this. So what is the mechanism? E2 mechanism, right? Like this, you can decide. If any other questions are there, I will give you later.